So we're going to begin today with talking about how to complete the square and what exactly completing the square means. So I know that you probably think, oh, if I'm completing the square, then I'm like taking a square that's partially drawn and I'm actually just finishing the rest of it. But completing the square in algebra is actually something completely different and has nothing to do with a geometric shape. Instead, it has to do with a trinomial. So remember, trinomials are going to have three terms. So everything we're going to deal with today is going to have three terms to begin with. And we need to understand not just what a general trinomial is, but what a perfect square trinomial is. Because perfect square trinomials are what we are going to be focusing on today. The idea of what a perfect square trinomial is. So in order to understand what a perfect square trinomial is, I'm going to give you the problem x plus 4 squared, which you see on your notes. So x plus 4 squared, we could think about that as x plus 4 times x plus 4. Because remember, when something is squared, like we have here, that means that there are two of them. So if I have x plus 4 times x plus 4, and we were to multiply that out, then we would do x times x, which is x squared, and x times 4 is 4x, and then 4 times x is also 4x, and 4 times 4 is 16. And I could combine my 4x's together, which would give me a total of 8x. So I would really have x squared plus 8x plus 16. This x squared plus 8x plus 16 is a perfect square trinomial. X squared plus 8x plus 16 is a perfect square trinomial. And the reason that it is a perfect square trinomial is because when you factor it, when you look at its factors, the factor is x plus 4 squared. Remember, when something's a perfect square, that means that it can be written as something squared. So that is the reason that x squared plus 8x plus 16 is a perfect square. Now there's some things that are specific about this that we're going to need to understand in order to actually do what is called completing the square. So let's start with, what does it mean to complete the square? It means to make a trinomial a perfect square trinomial. So what does it mean to complete the square? It means to make a trinomial a perfect square trinomial. Again, it means to make a trinomial a perfect square trinomial. And we're going to look at how we do that. In order to understand more about just what that means, in order for it to be a perfect square trinomial, we need to look at what happened after we FOILed x plus 4 squared. So we're going to start with that, x squared plus 8x plus 16. And I want you to remember something. First of all, I want you to remember that originally this was x plus 4. Right here, there was a plus 4 there. And we're going to look at how that plus 4 relates to this 8 and the 16 that ended up in our problem, because that's incredibly important. And hopefully you noticed, or you realized, oh, well, 16 is really 4 squared, and 8 is really 2 times 4. And that's important because every perfect square trinomial that we will work with will have a similar setup. It's a little bit different when we have coefficients, but none of the ones that we are going to work with will end up having a coefficient. So we're going to begin by deciding what would make these two expressions, what would it take for x squared plus 6x and x squared minus 10x to be perfect square trinomials. So what we need to look at is how they're currently written. And we can use this same format up here. Remember that there was this middle term was 2 times 4, and this last term was 4 squared. So notice they both again had that 4 in there. And that 4 is what matters. So we need to look at how x squared plus 6x is written. And if you think about 6x is really 2 times 3. So that means in order for this to be a perfect square, I would have to have plus 9 on the end. And the reason I would have to have plus 9 is because 9 is 3 squared. So x squared plus 6x plus 9 would be a perfect square. And the best thing about these and what makes them easy to identify and what makes them easy to work with is that when you factor this, it becomes x plus 3 squared. So that 3 was kind of like, you could say, our magic number in a way. It's the number that helped us A, complete the square, and B, it helped us learn how to factor it. So x squared plus 6x plus 9 is really x plus 3 squared. And the reason that is because 6 is really 2 times 3. And then we could add 9 here, and that would give us 3 squared. And that makes this a perfect square trinomial. There's no other number here that would work like that. So we're going to look at the next one. We have x squared minus 10x. And if we think about the number 10, so this negative 10 is really 2 times negative 5. So every time we've got to figure out how to write b, this middle part here. Remember, let's just a refresher, all of our trinomials are in the form of ax squared plus bx plus c. So b is always going to need to be written as 2 times some number. That's what we're going to do every time, is we're going to write b as 2 times some number, and then we will write c as that same number squared. So we just have to figure out what that number is every time. So in this case, negative 10 would be 2 times negative 5. So in order for this to be a perfect square, that means that I would need to add something squared on the end, and that something would be negative 5. Well, negative 5 squared is going to be positive 25. So x squared minus 10x plus 25 is going to be a perfect square trinomial, and it is going to factor into x minus 5 squared. And remember that minus 5 came from the fact that negative 10 was 2 times negative 5. So then we added negative 5 to squared to the end of our problem to make it a perfect square trinomial, and that's where the x minus 5 came from. So and you're probably wondering, well, why does all of this matter? What do I need to do? Like, why is this important? Well, we're going to be getting into quadratics next week, and we're going to be writing things in vertex form, and this is vertex form. So we need to be able to complete the square to get something into what we call vertex form. So if you glance down at the rest of our problems, you're going to notice they're a little bit different because now I have equations. I don't just have an expression that's missing something. I have a full equation. So it's going to change things a little bit, but not a lot. So the very first thing I always need to do is I always need to factor out a. I need to factor out the a value, whatever the a value is. And we'll talk about what that means in just a minute because it's not going to happen in our first couple problems. But we need to make sure in order for this to work, we have to have 1 as our coefficient of x squared. We have to have 1 there. So if you notice the first two, y equals x squared plus 14x plus 3, and y equals x squared minus 12x plus 14, they both have 1 as the coefficient. So since I have to have 1 there, those two are going to be fine. And from there, the rest is easy because for my next step, I'm going to take half of the middle term. I always take half of the middle term, which that's where this 3 came from here, because 3 is half of 6, because remember we had to write it as 2 times something. That basically means I'm dividing it by 2. Half of negative 10 was negative 5, because again 2 times negative 5 gave us negative 10. So I'm going to take half of that middle term, and I'm always going to square it. I'm going to square that part so that I can add it to the problem. Now, here's where things are going to get a little bit weird, or a little bit different than what we've had so far. What I need you to remember is that whatever you do to one side, you must do to the other. Whatever you do to one side, you must do to the other, because that is called the property of equality. We have to keep our equation balanced. So before, up here, the two problems we were looking at originally, they were just expressions. There was no equation. We could do whatever we wanted to them because we're just using those for samples. Here, I have an equation that I've got to work with, so it's going to change things just a tiny bit. So let's start, and after, by the way, step 3 is after I take off the middle term and square it, then I need to rewrite in factored form, which that is easy. Okay, so we're going to begin with y equals 1x squared plus 14x plus 3. And I'm going to rewrite this first, and I want you to write it this way as well. So we're going to write it as y equals, but it's going to be y and then a space equals x squared plus 14x space and then plus 3. I know this seems very weird, but in a second you're going to start to understand why. So in order for this to be a perfect square trinomial, I need to have something that I add here that will make this whole thing, the x squared plus 14x plus whatever this part is right here, a perfect square. Now, the rule says, though, if I do something to one side of the equation, so that means if I add something to the right side of the equation, I have to add the same thing to the left side of the equation to keep it balanced. So that's why we left these spaces here. So we're going to go back to what we were doing before. In order for this to be a perfect square trinomial, I have to write 14 as 2 times something. So we just have to figure out what. So we know that 14 is really 2 times 7. So that means that in this other blank here, we are going to be adding in something squared, and that something is going to be 7. Well, 7 squared is actually 49. So really I'm adding 49 to the right side, and whatever I do to the right side, I also have to do to the left side. So I must add 49 on the left side as well. And the reason I'm doing that is because whatever I do to one side of the equation, I must do the exact same thing to the other. So if I add 49 to the right side, I have to add 49 to the left side. Well, now when we look at it, we know that the left side, well, that's easy. That's right now y plus 49. We're going to do something else with that in a second. Equals this right side, recall from what we did a minute ago, that x squared plus 14x plus 49, this part's going to factor really nicely, and it's going to factor into x plus 7 squared. And then I still have this plus 3 that was on the end of my problem. Well, I'm almost done. So the last thing that I have to do is I really, really, really don't need this plus 49 over here on the left side. I really need to get rid of that. So in order to get rid of that, I'm going to minus 49 from the left side. I'm going to minus 49 from the right side. So my final problem really becomes y equals x plus 7 squared minus 46. And this right here is in what we call vertex form. And this is a little more information you need right now, but we're going to talk about that next week. So this right here is called vertex form. And what this helps us do is it helps us identify the vertex of a parabola or the vertex of a quadratic. So this is why we want to complete the square. So we're going to do the next one, y equals x squared minus 12x plus 14. So we're going to set it up as y blank equals, and we're going to be a little specific, we can do y plus because that's what we're going to do, equals x squared minus 12x plus blank plus 14. And we will always, always, always be adding this. That's what has to be true in order for it to be a perfect square trinomial, is this has to be a plus. So the first thing I need to figure out is how to write negative 12 as 2 times something. Well, 2 times negative 6 is going to give me negative 12. So that means that this blank here really needs to be negative 6 squared. And negative 6 squared is going to be 36. So if I add 36 to the right side, remember, I must also add 36 to the left side, because whatever I do to one side of the equation, I must do to the other. So my left side is really nice and simple. Y plus 36 equals, remember the right side, x squared minus 12x plus 36. This factors really nicely, and it becomes x minus 6 squared. And I'm going to bring down that plus 14 because it was there. And then to get it into the final form, I'm going to minus 36 from both sides just so that it looks prettier. And I get y equals x minus 6 squared minus 22, because 14 minus 36 is negative 22. And this would be my final answer. I have now completed the square so that I could make x squared minus 12x a perfect trinomial so that I could factor it and it would end up as something nice. Now we're going to look at y equals 8x squared plus 40x. So I'm first going to rewrite this as, on the left side, y plus blank equals. Now, let's think back to the steps that we wrote up here at the top. Because the very first step that we wrote is that we have to factor out the a value. We didn't talk about that yet because we haven't had that as a problem, because for the first two problems, a was 1. But notice here, a is not 1, a is 8. So I have to do something a little bit different with this problem. And that little bit different part that I have to do is that I have to factor out this 8. So if I factor 8 out of x squared plus 40, 8x squared plus 40x, I'm left with x squared plus 5x. And then I'm going to add this plus blank here like I have been before. And that is going to give me, or help me, get my perfect square trinomial. So just like before, I need to rewrite 5 as 2 times something. Well, 2 times 5 over 2 is going to give me 5x. So that means that this blank here is going to be 5 over 2 squared. And 5 over 2 squared is actually 25 over 4. The reason I got that was because I took 5 and squared it, I took 2 and squared it, and I got 25 over 4. You're welcome to use your calculator to help you out with this stuff. Now, this next part is going to be a little bit different, because normally we'd be like, cool, I added 25 over 4 to the right side. That means I need to add 25 over 4 to the left side. Well, that's not wrong, but that's also not completely true. Because remember, and pay attention to the fact, this 25 over 4 here is in parentheses. So that means that initially I need to distribute this 8 in here. So what I'm actually going to do is, to the left side, I'm going to add 8 times 25 over 4. And this 8 here was because that was my GCF that I factored out. This 25 over 4 was from what I added to the right side. So in order to keep it balanced, I had to do the 8 on the left side and I had to do the 25 over 4. So we can do some math to make this a little bit prettier. I have y plus 8 times 25 over 4 is going to give me 50 equals, and then we have our 8 that was our GCF times, well, just like earlier, this x squared plus 5x plus 25 over 4 factors really nicely, and it factors into x plus 5 over 2 squared. So I'm almost done here. I have to get rid of this plus 50 just because on the left side it just doesn't look pretty, and we want it to be just in y equals form. So I'm going to minus 50 from the left side. I'm going to minus 50 from the right side. I really can't minus 50 from anything over here because this 5 over 2 is in parentheses, and this 8 is attached to the parentheses. So my problem is going to end up being y equals 8 times x plus 5 over 2 minus 50. And this is my equation in vertex form. So our next problem is y equals 6x squared plus 25x. So I'm going to rewrite this as y plus something equals, and remember again, we need to factor out the GCF, so we need to factor out this 6 here, which is not necessarily the GCF, that's important to remember, but we need to factor out whatever this a value is. because we cannot have that. So even though when I try to do this problem, if I divide both of these by 6, 25 isn't really divisible by 6, I still have to do that. So I'm going to have 6 is what I'm going to take out, and then I'm left with x squared plus 25x over 6, or 25 over 6x, and then plus my blank, whatever it is that I'm going to add to the right side here. So I need to figure out how to write 25 over 6 as 2 times something. Well, really all I'm doing is dividing it by 2. If you're not sure how to do that, then in the calculator type 25 over 6. You can literally type this what I'm about to write, 25 over 6 divided by 2, and that will give you the answer. Or, for those of you that have a good math understanding, then you know that all we have to do is really multiply the denominator by 2. Because I'm dividing it by 2, I'm multiplying it by 1/2. So really this becomes 25 over 12. So sometimes we get some really ugly numbers here, but that is okay. We can work with those. So that means that my blank on the right side needs to be 25 over 12 squared. Well, 25 over 12 squared is actually 625 over 144. So a pretty ugly number here, but that's okay. So then on the right side, I also have to add in my 625 over 144. But remember, we factored out a 6 to begin with, so I have to account for that as well. So this 6 here needs to get multiplied on the left side as well. And that was from my A value that I had to factor out. So the left side, let's make that a little bit prettier. I get y plus, I'd use your calculator to help figure that out. It ends up being 625 over 24. But you may want to, again, use the calculator to make sure that math is right, which I'm telling you it is, but that would be my suggestion to you, equals 6 times, and all of this x squared plus 25 over 6x plus 625 over 144 is going to factor really nicely into x plus 25 over 12 squared. And the only thing I have left to do is I really don't need this plus 625 over 24 here, so I'm going to minus 625 over 24 from the right side. And I'm also going to, or from the left side, then I'm also going to minus 625 over 24 from the right side. And I end up with y equals 6 times x plus 25 over 12 squared minus 625 over 24. Again, some really ugly numbers there, but this is really going to come in handy when we start talking about quadratics next week and things in what we call vertex form. So I got a couple more here that we're going to do, 3x squared plus 12x minus 9, and then we got one more that we're going to take care of. And notice this one's a little bit different than the last two because it does still have the a value here that we're going to have to get rid of, but it has a c that we haven't seen in the last two. So these are going to work just, again, a little bit differently, not a whole lot, I promise. It's not going to be anything like super different, but it is going to be just a tiny bit different. So we have y plus, we're going to rewrite this as we always rewrite it, as y plus blank equals, okay, we are going to factor out this 3 here because that was my a value, but what's going to be different is I'm not going to factor it out of this 9 here. I am not going to factor it out of this 9 because this minus 9 will not end up as part of our perfect square. So we don't want to factor that 3 out of that. So the 3 divided by 3 gives me x squared plus 4x, and then plus my blank, and then on the outside, close the parentheses, and then minus 9. So notice that I closed my parentheses, and then I put my minus 9 out there. That is why we did not factor that 3 out of that, because we don't want to include that in what is going on in here, which is the part that we need to make into a perfect square trinomial. So this one's a pretty easy one as far as numbers go because 4, that's really simple. 4 is 2 times 2, which means that this blank on the right needs to be 2 squared. And 2 squared is actually 4, so I'm adding 4 on the right side, which means on the left side, I'm going to add 4 times 3. And remember, this 3 that I'm multiplying by here is because that was my GCF. Now, you don't necessarily need to write down what I'm about to show you, but some of you are still wondering, why does all this matter? Why am I multiplying by 3 on the left side? What does this 4 have to do with anything? What happens here? Like, where is this coming from? So I'm going to work out this problem. I'm going to stop doing this problem the way that we need to do it for right now, but I'm going to work this back out because I want to show you that this problem right here, this y plus 3 times 4 equals 3 times x squared plus 4x plus 4 minus 9 is equivalent to y equals 3x squared plus 12x minus 9, because it's important for you to understand that. So again, I'm doing this so you can see that they're equivalent, so I don't need you to write this down unless at the end of this you think it might be beneficial to you. But for right now, don't write this down. So I just want to show you that I'm not actually changing anything. I'm just rewriting the problem differently. So on the left side here, I have y plus 3 times 4, which is 12. On the right side, I'm actually going to go ahead and I'm going to distribute this 3 in the parentheses. So 3 times x squared would be 3x squared. 3 times 4x would be 12x, and then 3 times 4 would be 12, and then I'm going to bring down my minus 9 that was already there. I'm going to simplify the right side, so it becomes y plus 12 equals, oops, I forgot my squared there, sorry, 3x squared plus 12x plus 3, because 12 minus 9 is 3. I'm going to minus this 12 on the left side, and I end up with y equals 3x squared plus 12x minus 9. And what I want you to see is that what you have here after we manipulated this equation is exactly what we started with. Y equals 3x squared plus 12x minus 9. They are the same. So all we're doing is we're not changing the value of our problem. We're just changing the way it's written to a more helpful form. And this helpful form is this idea of completing the square. Okay, so let's finish this problem up. Let's actually write it as a perfect square trinomial, or in what we call vertex form. And I end up with y plus 12 on the left side equals 3 times, and remember that this x squared plus 4x plus 4 is going to factor really nicely into x plus 2 squared. I'm going to bring down that minus 9. And the last thing I want to do is I want to get rid of this plus 12 on the left side just to make it a little bit prettier. So I'm going to minus 12 from both sides. And I end up with y equals 3 times x plus 2 squared minus 21. So this right here, x squared plus 3 times x plus 2 squared minus 21, this is our vertex form. We have now completed the square to make this trinomial look better. And I know you're probably thinking this doesn't actually look better. This looks more complicated. But I want to, again, this is something you don't have to write, but I want to verify for you that this form that we have right here is the same as what we started with. So I'm going to rewrite this first of all as y equals 3 times x plus 2 times x plus 2, because x plus 2 squared is really 2x plus 2's, minus 21. On the right side here, I'm going to FOIL. X times x would be x squared. X times 2 would be 2x. 2 times x would be 2x. 2 times 2 would be 4. I'm going to bring down my y equals 3 times all that and my minus 21. So I can simplify this a little bit. Y equals 3 times x squared plus 4x plus 4 minus 21. And then I can distribute, because I have this 3 outside here. So 3 times, I have y equals 3x squared. And then 3 times 4 would be plus 12x. And 3 times 4 would be plus 12. And then minus 21. And then I can, in fact, combine this plus 12 and this minus 21. So I really have y equals 3x squared plus 12x, and 12 minus 21 would be minus 9. So this is, after I've worked out the entire problem, that's what I end up with, and compare that to the original problem, which was y equals 3x squared plus 12x minus 9. And that's what I got here. Y equals 3x squared plus 12x minus 9. So I just want you to see that all we're doing is we're just manipulating these equations, like I said a minute ago, to be something more helpful to us. That doesn't mean that they're necessarily going to be prettier, but they're going to be more beneficial, especially when we get to what we're doing next week. All right, we're going to finish this up. We have y equals 2x squared minus 15x plus 4. And we're going to rewrite this. We're going to complete the square to make this a better problem. So I have this as y plus blank equals. I do have this coefficient here, this 2, that I need to get rid of. So I'm going to factor out that 2. And I'm going to divide a and b by that. So if I factor out the 2, then I'm left with x squared minus 7 over 2x plus blank, and then my plus 4. So we just have to figure out what that is. So negative 7 over 2, if I rewrite that as 2 times something, that actually becomes negative 7 over 4. So that means that in this other blank, I need to add in negative 7 over 4 squared. And negative 7 over 4 squared would really be 49 over 16. So if I add that on the right side, I also have to add 49 over 16 on the left side. And then don't forget that I do have to multiply all of that by the 2. That was my my factor that I took out there. So the left side is going to look much nicer. It'll be y plus 49 over 8. Again, use your calculator to help you with that math if you need to, equals 2 times. And then all of this mess right here, this x squared minus 7 over 2x plus 49 over 16, all of that is going to factor, and it's a perfect square trinomial. It's going to factor really, really nice. And it is going to be x minus 7 over 4 squared. And I'm going to bring down my plus 4. And then just to make this a little bit prettier, I'm going to minus my 49 over 8 from both sides. So minus 49 over 8. And I end up with y equals 2 times x minus 7 over 4 squared minus 17 over 8. And the way I did that was I rewrote 4, in case you're wondering. I rewrote 4 as 32 over 8. And then I did 39 over 8 minus 49 over 8. You can also, again, use your calculator if you need to help you with that math. So 2x times x minus 7 over times x minus 7 over 4 squared minus 17 over 8 is my final answer.